Welcome everyone. My name is Brian Jimerson. I'm with Pivotal, a platform architect.
I'm Brian Gregory. I'm with Google. I'm a cloud advocate.
And today we're going to talk about Cloud Foundry and the Google machine learning APIs, as well as Spring and how they all integrate together. So what we want to do is sort of go through how all the Google services that are available on Google Cloud Platform are available for Cloud Foundry consumption for applications running Cloud Foundry. You can see that there's quite a few services that are available. Right now, the service broker for Cloud Foundry that Google has created has exposed these services, but you can always expose more services based on customer demand. But is everybody familiar with the service broker concept in Cloud Foundry? Yeah. All right. I wanted to hear a little 100 yeahs. So what I want to do is just show how simple the Cloud Foundry, the GCP Service Broker is in Cloud Foundry. You can see that, oops, hold on a second. You can see that I have a Cloud Foundry instance running, and in the marketplace, we have the GCP Service Broker installed, which exposes all these services for your application to consume, just like it would any other sort of service. So it's a very simple integration to be able to connect to GCP SQL or storage or even some of the machine learning APIs that we're going to demonstrate today. That'll give it back to you. Uh-oh, we lost it.
Okay, yeah, one of the things I want to add, this will be updated as time goes on, and so customer demand kind of drives what's next, what features are available in native and PCF, so make sure that you're voicing that to your account teams and whatever to feed that back into our ecosystem so that we can get those things on the books. Today we're going to talk about, basically we're going to focus on machine learning inside that's available in PCF, so that's going to be the pre-trained model. There's two models, obviously, goes a little bit deeper on the build your own, and then we have the pre-trained that's natively available in PCF. These models that we're going to use today have been pre-trained in Google's own domain with Google's data sets and with our expertise. To use them, all you have to do is a simple API call, or again, service broker inside of PCF. First, we're going to talk about translation API. It supports more than 100 languages, and it's highly responsive for fast, like immediate translation, if you want to leverage that. People might ask, like, why would you use this? Why would you want translation API? At the end of the day, if you think of something like Airbnb, that it's a global company and people speak many different languages, it'd be kind of hard to communicate or find maybe a home that you're interested in renting, or if you were trying to read the reviews if you didn't understand what the consumers were saying. So there's a thing. You can also think of the makers like a Clash of Kings. That's a global real-time translation that's happening there so that people can communicate with each other globally. Cloud Vision API, it's not only detects individual objects and faces, also within images, it does printed words and other things as well. So that's the Vision API allows you to understand the content of any image that you're looking at, encapsulating powerful machine learning models. It quickly classifies the images as well so that you can sort them by category based on nouns. What do you want to do this for? You're basically looking to gain insight from your images. You want to moderate, inappropriate content. You want to do sentiment analysis. And I think that's listed up there. Using the API, it quickly categorizes things into thousands of categories. I'm going to show you here a demo just in a second that goes through that. It finds and reads printed words again within there via the image API inside the video. So it's also kind of doing a text translation via image. Again, you're wanting to understand the content of an image. Obviously, you're getting value from it, and then you can build apps towards that, like based on the feedback and what data you're gathering from this. So a few examples of this, right? If you wanted to, if your job was to detect inappropriate content, violent content for that matter, spoofs, or you had medical data that you needed to protect, that would be a reason. If you're doing sentiment analysis, if you're trying to build applications that are able to detect faces, object, logos, emotional facial attributes, then you would probably use this. And metadata. So if you need to understand the contents of the image from everyday entities to logos to landmarks, that's another reason why you would use the video API. You can also extract text when you need to extract data from receipts, invoices, and images and gather that data. And again, there's a lot of use cases, and we're going to go through some of those in a minute, why this will all make sense. We'll do a demo and show that, put it all together. Cloud Speech API. So if you think of it as voice-enabling chat, voice-controlled games, home automation, like everybody's doing it these days. That's not the slide I have. You can convert audio to text by applying our powerful neural network. You can support globally over 80 different languages. You can transcribe audio to text as well. For sentiment analysis and entity recognition is inside the piece of the text. You can also gather that data with our language API. Entity recognition identifies entities, labels, types of persons, organizations, events, things of that nature. Multi-language support, again. Syntax analysis, extract sentences, identify parts of speech, and create dependencies. You know, you might be like, well, why would we do this? You know, why should we care? Identity, on the identity entities, you know, you're looking to build relationships and graphs, understand most important entities. The sentiment analysis, you got a -1 to 0.1 polarity of sentiment, or a 0 to infinity, a magnitude of sentiment. Why do you care? You're understanding product reception, right? If you release a product, you want to know how it's perceived by your consumers and the customer. You might want to use it for call center logs to see how your call center is doing, and then also on the flip side, how your customers feel about this experience that they're having. So you can create a full view of customer behavior, sentiment, emotion, intentions by leveraging structured and unstructured data. I think what it really does at the end of the day, it allows you to create a 360 view of your customer to fully understand them and deliver a better experience to your consumer, whoever that might be. So on the Cloud Video Intelligence API, again, you're extracting actionable insights from video. It's not too different from what we talked about before with the image. It allows you to make sense of large amounts of video files in a very short amount of time. I'm working with a customer now that has petabytes of video footage, and they're just sitting on the shelf, so they've cataloged those, and now they can search those images or the videos and tell you like what keywords, where they live inside those videos, at what point, and they can go straight to it. So they're actually getting value out of these videos that they've had for years and years, and now they're able to use those to monetize on that data. It helps you also build and understand your overall content. It's like searching your desktop or searching, you know, a text file. You're able to search like what you have inside your video by, if you're looking for baseball, right, it'll show you references to baseball, baseball fields, baseball players, baseballs, things of that nature. Using the Video Intelligence API is in action. So here's what I did. So I loaded a 15-second clip. You can do this too online. And you'll see that it shows keywords that you can't read because it's really, really small. But the point is, it shows you what keywords it picked up out of there: class of car, antique car, the type of car, what else was in the video, like logos that were created, and it also shows you exactly where those live inside your video, which is those little red marks. So you can try that online with any video you want and see for yourself the results. But that was just a snapshot I did there, but there's like a lot more. So it's going much deeper, really doing an overall analysis of your video. And again, this was a 15-second video, so it's actually a lot of data that comes out of that. I would recommend everybody go try it just to see how it works and how well it works. Use cases are across all industries, range from predictive models, deep analytics, to proactive health management. There's really no market that couldn't benefit from some level of machine learning. And some of these slides I put in here so you can read later if you want to download the content. So we have a full suite of products at Google to help you with your journey, whatever that might be. This kind of shows what you're about to see in a second, which is the demo that we're going to go through. You take it from far left to far right. You're taking data. You're going through a bunch of different tools. On the right, you're looking for an outcome. Like, what are you going to do with this said data? Right? You found this data. How can you use it? It's structured, unstructured, whatever data you've gathered. Like, what do you want to do with it, and how do you want to use machine learning to deliver value for you or your customers? Which leads me to the next part of this conversation. I was able to meet, there's a fellow Googler, and there's also a Mike Goddard and Scott Truitt that were working on a project I just found out about recently. This is a perfect demonstration of like taking data and doing something with it. So some other people have collaborated on it, so I'm sure I'm gonna miss somebody. I think Duncan Rutland, a fellow Googler, kind of had the concept. But what they were looking to do is say, like, what can we do? Let's take some random data, right? And let's think of something. If we got Twitter data, what could we do with this data? So then they just said, well, let's create this customer. Could we proactively say, I'm going to read this from this person, and then I'm going to be able to come back with an offer or something valuable for this customer that they're asking for? Again, using machine learning to say, what are the keywords, and then on the back end. So as a business that was created as well, Boho Chic was created, and they were going to be the business. The goal was to use a customer's tweet to analyze the data and to create a personalized sales offer and give them like a discount, more importantly, show them a location, check their inventory and see if it's actually somewhere in the region, and then give them Google Maps to get them to that location to pick up whatever it is they're looking for. So next is our customer, is Mia. She's a customer in this scenario. She's loyal to Boho Chic, and she shops with them often, and she has plenty of people trying to get her business. She's also connected, just so everybody's clear, like we're not just scanning the internet and stealing all this information. She's connected with them on Twitter, right? So they see her tweets. They also go out and are actively looking for when someone tweets. What are the keywords? What did they put in there? Did they put in their dress, the color, something like the sentiment was love or hate? Obviously, you would not want to extend an offer to somebody that hated your product. Probably, maybe reach out with a coupon or something else there. But that's kind of what they were looking for. And we really wanted, this demonstration to be about like, let's use a real life example that people could relate to. We all love cats and dogs and showing those things, and they're really neat. But I think this would be a better demo for us to show here. So the experiment is Mia is going to tweet about, some dress that she needs for this weekend's party that would be great. She found it on Pinterest or other, and she has no idea where they sell these things. So she wants to figure out like, hey, does anybody know, like, I'd love to have this dress. Can we find the perfect dress for her? Can we make an offer that she can't refuse? Send her the location to go pick this up, check our inventory to make sure we actually have it first before we send her there, because that would probably not make her very happy. And more to the point, can we build data-driven like personalization into apps, like right using unstructured data? Can we do that in a way that like delivers a personal experience to someone, tailored specifically to them, and then also obviously benefit from it from a monetization standpoint? So here's the original mock-up. They want to use the data to understand the customer. They're going to need to match the item in their stock to make sure they have it in their warehouse or something similar. They're going to return potentially up to 10 different items for her. They want to send a personalized discount code for 30% off. And again, they want to send her a location to where she can pick this up. Brian's going to come back over here now and do a quick demonstration of the dress that he wants everybody to see him buy.
Yes. So this is the architecture for, actually let me do this, I apologize, so that I can see the dress I want as well.
I can't tweet about wanting a dress, so he's got to do that.
All right, so do this again. So this is the architecture of the application that we're going to demonstrate. And I know this is kind of small, hard to follow, but if you look over here, the data, really the source of the data is a Twitter ingest app. So there's an app that's pulling Twitter on Mia's account and looking for certain types of tweets. And that gets fed into a Spring Cloud data flow source. So for those who don't know what Spring Cloud data flow is, Spring Cloud data flow, or SCDF, is a framework for building microservice-based data ingestion apps. So we used to have something called Spring XD previously. It's since been re-architected in Spring Cloud data flow. So it's really, it's a mechanism to have sources and sinks and pipes and filters between those sources and sinks. So in this case, it's going to be fed into the Spring Cloud data flow source, and then the processor is actually going to make calls to, as you can see down here, to the Google Cloud Vision APIs, as well as the natural language processing. It's then going to use RabbitMQ and the persistent service to store the information into Google Cloud Data Store, do an inventory match if there is any inventory, as well as retailer inventory through Google Cloud TensorFlow, and then ultimately send it to the sink, which is going to be a reply to the tweet if there's matches found in there. And also we have a demonstration UI. So let me bounce over here. So you can see in Cloud Foundry, let me make this. There's a number of applications that comprise the whole solution, as well as a bunch of services, mostly Google Cloud services, as well as Redis, RabbitMQ, and MySQL. So if I go to, I'm logged in as Mia, and I take a picture of a dress that I think is cute, which I do think this is cute. I go, OMG, this dress is so cute. That's pretty positive about that, right? Actually, let me do this first. One of our apps is not behaving properly. We have to restart it occasionally. It's Python, that's why. There's no Python developers in here, is there? So I'm going to go ahead and tweet this. And this is kind of our back-end sort of UI. You can see sort of flow that's going along there. Wait for it to pick it up. This is the last one I tweeted. Of course. Okay, so now you can see that it saw this tweet with this picture of this dress in here. The Cloud Vision API picked out a number of keywords out of here: clothing, day dress, so on and so forth, fashion model. Maybe that's part of it. And really the sentiment analysis did a natural language processor. So in this case, OMG, this dress is so cute, was taken as positive. So they should make an offer. Stored a lot of this information in Google Cloud Storage, location, Twitter name, preferences, and so on. Try to match inventory in different retailers, and ultimately responded to that tweet with a number of matches that they found in inventory. So if I come back over here to Twitter, you can see there's one. Oops, sorry. Why won't it let me do this?
It's below it.
Where is it?
It's just right there. If you scroll down.
It's already in there. I apologize.
You gotta use Twitter to understand.
Yeah, I'm not a big Twitter fan. So you can see the reply.
He just wants the dress.
Yeah, I don't
he
like
didn't want
this
to deal
dress.
with the Twitter stuff.
I don't like this dress, but I like this one. And if I tweet something that's negative, let's see if I put this in there. This dress is so ugly. I was going to say something bad, but we won't. Let that pick that up. So you can see that because I put this dress in here, the sentiment analysis said that it was negative. So we don't want to make an offer. So there's not going to be any reply to that, because obviously I don't want anything like this dress. And the dress is ugly. So that's our application. I think it's a pretty good example of using a lot of the machine learning APIs within Google Cloud.
I want to add, the guys that originally started working on this project were not familiar with Google Cloud Services. They were definitely familiar with Spring and Python, obviously. But when they started to do this, right, they just leveraged the Service Broker, and they talked about the ease of use and how easy that was for them to do it. They didn't have to go build some algorithm on the background to do all this magical machine learning, right? They could just plug in and use it for their benefit.
So the PCF services that were used within this were RabbitMQ for message brokering, MySQL as a relational database, Redis, as well as the GCP Service Broker that's been installed on there. I think the other important thing with the GCP Service Broker is that PCF does not have to be running on GCP to consume Google Cloud services. It can be running on-premise or any other cloud for that matter. So a little bit more detail of how the application works. The Twitter adapter app periodically updates its list of followers. It pulls the timelines. It delivers outbound offers, and users opt in by following them. So again, it's a Python app, which explains a lot. This is kind of the graphical interface for Spring Cloud Data Flow for that flow. It really is a GUI interface for building out these flows. You can see here's a source, some sort of processes that happen in between, and then ultimately it's sent to a sink for an offer. You can write your own processors. There's some out-of-the-box ones as well as sinks and sources. The data science interrogator, it does some sentiment analysis through natural language processing. What are they talking about? Is it clothing or is it something I have no idea how to sell? And then ultimately uses machine learning API for natural language as well as a vision API. You can see in here, this is the machine learning vision API and the output for that particular dress that was posted. So you can see it's the high percentages are very accurate. White clothing, it's a day dress. I don't know what a day dress is, but probably should. And then the images for the inventory are stored in Google Cloud Storage with a certain naming convention that it can parse. And the data science evaluator then calls the inventory to match the application based on the Vision API output, and also generates a Google Map link for the tweet. And again, there's some more technical details behind there, but we don't have to go through all of them. So that was about it that we had. Are there any questions or comments? I don't know, we're the last ones, so we want to get everybody out of here. Sure. Do we need a microphone, I think? Do they need a microphone? Or?
Maybe you could just repeat the question.
Sure.
Okay. So using the Google API directly versus using a tile.
Sure.
So can you characterize the usage way and advantages, disadvantages?
Yes. So the question was, what's the difference between using the GCP APIs, machine learning APIs, directly versus using what we call a tile or the service broker within Cloud Foundry. So the actual going against those APIs, integrating with those APIs is exactly the same. What the service broker does is allows developers to discover the available services that have been made available to them and get connection information in their application to connect to them. At that point, it's exactly the same, whether you're running standalone or in Cloud Foundry or anything else. So the service broker concept is really an abstraction for service discovery and connecting to services, whatever they might be.
And the one thing I wanted to add is that you can go out on Google and try all of these APIs for free if you want to play around with them. Like, this is one of the kinds of things we blew through here, but you can basically say, like, what's a sentiment, which is actually kind of funny because if you put I hate Brian, but it backfired because I'm Brian too. Like, I was trying to be a funny guy and stuff. Like, it comes back with some interesting things, right? Like, clearly says it's negative, but then it also linked like a link to Wikipedia for Brian the dog, right? It's like, well, wait a minute. Like, apparently everybody hated him. So it's interesting stuff, and you should play around with it to use the sentiment analysis forms.
Any other questions?
So there was no training involved? Just a picture, apply some pictures, and so how did you determine where to go up for things and find possibilities?
Yeah, so they.
Repeat the question. Repeat the question.
Yeah, can you repeat the question?
Oh, no, I was saying you should.
Oh, like I couldn't hear all of it. I just heard the first part.
So, first part of it was, did you have to do any training from what you saw on the tweet to what you found in some inventory? Then, whatever the answer to that is. Then secondly,
So Mike Goddard was the original person that worked on it, so I can't talk to the second question. The first one, I know that he scanned basically the top 250 for different categories and then downloaded those and plugged them in and created their inventory based on Google searches, right, to go find red dresses and popular dresses and all these different styles, and then loaded all that data into a system to create his inventory, and that's what they went off of. So when you're matching and those are pulling, those are actually in the database that we've stored as our pretend shop that we've built. So that's where that came from. But the second part is, like, I don't know the methodical approach to why he did what he did from the...
So the second part, Spring Cloud Data Flow, is really the piece that stitches everything together. So if you're familiar with something like enterprise integration patterns, which is a fairly common thing, Spring Cloud Data Flow follows that quite a bit. It's actually built on Spring integration. So Spring Cloud Data Flow is really that piece that where it's, dumb pipes and smart filters concept, where it pieces all the different components together into a flow of data. So it connects to Rabbit, it connects to Google Cloud Storage, it listens on, it connects it to Twitter, all those things. So. Anything else? All right.
One last second to plug. The machine learning stuff is not the only things that are capable out of the box with PCF. PCF, you also have global load balancing out of the box. We didn't have that covered, obviously, today in the session, but that's just something to think about. If you start to look into like what native capabilities come from GCP, being in PC, with PCF running on it, or like Brian said, you don't have to necessarily to leverage, to consume our APIs, but you could come up and ask questions or send me, whatever you want to talk about. Like, there's a lot of other offerings besides machine learning that we have available.
Awesome. Well, thank you, everyone.